Hey guys, and welcome to video number 56. Thanks for joining me again. This one is on solving inequalities. The keywords here are inequality, integer, and solve. An inequality is something that is not equal to, and we have four different symbols that we use to represent different inequalities. Integer is a whole number, and solve means to find the value of the missing letter. We've done a whole lot of solving things in this algebra section so far. We've solved one-step and two-step and three-step equations. We've solved equations that have got brackets in. We've solved quadratic equations. We've formed and solved equations. So this one is just solving inequalities. And the good news is that we can use exactly the same method as you would use to solve regular linear equations. Okay, so same thing to both sides method. If you haven't watched the videos on those things and you feel like you need to, please do that before you watch this video, so I don't have to keep explaining things in great detail. You may be asked to represent your solutions on a number line. That's possible. Again, that's in an inequalities video that I've made previous to this one, and you may be asked to list the integer solutions as well, which is also in that video. So question number one, solve the following inequalities. Now, A is just a two-step equation, or a similar sort of thing to a two-step equation. It's a two-step inequality. We write out the inequality, put the lines down either side of the inequality symbol, which means less than. We add 5 to both sides, leaving us with 2x on this side and 12 on this side. And then we divide both sides by 2, and leaves us with x is less than 6. Okay. Now that means that x is able to be any value that is less than 6, not including 6, not allowed it to be including 6. There's a different symbol for that. So if we put 5 in, which is the whole number that is, or the closest whole number that is less than 6, 2 times 5 is 10, take away 5 is 5, and 5 is less than 7. And that would make a true mathematical statement, as would any number that is less than 6. Okay, even negative numbers, you could put them in, 0 you could put it in, and it would make a true statement. If you put 6 in, or you put anything above 6, it wouldn't make a true mathematical statement if you were to substitute that value in. And that's what we're doing. We're finding the number, the range of values that would work. Okay. In B, it's much the same thing. 10x plus 32, but this time I'm using the more than symbol. So seeing what I do again, ooh, a bit wobbly. I'm going to take away 32 from both sides, leaves us with 100 there. 10x on this side, and then divide by 10. So that's really simple. X is more than 10. Okay, so we've got to choose a number. If we were going to check it to see if it worked mathematically, true statement, X is more than 10, yes, it will work. If we choose 11, it will work. All right, I'm not going to do that. You can check it for yourselves if you don't believe me. Now, C, we've got 2x plus 6 over 7 is less than the same as 2. So different symbol, fraction on this side. It doesn't really matter. It's the three-step equation. I've done a video on that with fractions in, similar sort of thing. So just do the same things you normally would with that. So you're going to multiply both sides by 7. Leaves you with what's on the top of the fraction after you've got rid of the divided by 7 bit by multiplying by 7. Multiplying this side by 7 gives you 14. And then you're going to take away, this symbol just comes down all the way through, just like the equal symbol does. Take away the 6 from both sides. That leaves you with this, and then divide both sides by 2, and it leaves you with the answer. And you just got to make sure you write it in correctly. Nothing else to worry about there. Okay, so hopefully, I know I've gone through that pretty quickly, but it's, yeah, like I said, in other videos, so watch them if you are not sure what I have done in great detail there. Now, in question 2, I've got some slightly different ones. I've got to solve and represent the solutions on a number line this time. So if I solve it, I'll put that here, and I'll write the number line over here if I can. So x plus 1 is less than 3x minus 18. So lines down either side. Okay, side that's got the least amount of x's. So this is a three-step equation. If you want to know how to do these, watch that video. Take away the 1x from both sides, leaves us with 1 on that side. Don't have to put the plus in front of that one now. Now that's the only thing that's left there. And then we've got 2x there, and we've got minus 18 there. And if we then add 18 to both sides, we're left with 19, and then 2x on that side. Divide both sides by 2, which is 19 over 2. Okay, but this time we've got 19 over 2 is less than x, which is a bit awkward. All right, normally we have the x on the other side. I mean, it's the same. It's going to be the same thing, but we want to know what x is on the left-hand side. So we have x, and then we're going to flip the inequality round. Okay. That's what you do if it's on the other side. and it kind of makes mathematical sense. What is 19 over 2? 19 over 2 is 9.5. So if you substitute a number in, so x has got to be more than 9.5. Let's put 9.5. All right. Let's think of a number that is bigger than that, 10. All right, and then we'll see if that works in our inequality. And if it does, then we know we've definitely got this right. Okay, so 10 plus 1 is 11. 3 times 10 is 30. Take away 18 is 12. So this would give us 11 if we substitute the value of 10 in. All right, 11 is less than 12. Now, is that mathematically true? Is that a statement that is true? 11 is less than 12. I think we all know it is. So we're going to pop that in, and I'm going to put in 9.5. Okay, you could put 19 over 2, it wouldn't matter. All right, so let's get rid of that, put the answer in there, and then I'll pop that on a number line, just so you know. Now, I have done the number line stuff in the other video, like I mentioned before, so I won't whiz, I'll just whiz over it. There you go. Here's a bit of a number line. That number's going to be 9, that number's going to be 10, that number's going to be 11, so 9.5's in the middle there. Dot above, pointing that way, arrow coming from it, not coloured in dot. Okay, and I explain why in the other one. That's for A. Now, B, let's do B. So we've got 2 and then 2y minus 8 in brackets, and then minus 4. So lines down either side. Try and squeeze this in. Multiply both. Multiply out your brackets. Sorry. So you've got 4y minus 16 is more than minus 4. Add 16 to both sides. But if you had 16, you took away 4, you'd have 12 left. So we've got 12 on this side, 4y on this side, and then divide both sides by 4. Leaves us with y is more than 3. And I will try and squeeze a number line in. So I've got a bit of room to work this next one out, actually. So I'll squeeze a number line in above it. So there's a little tiny number line. We've got the number 2, 3, 4. Let's have another one there. 5. So dot above, arrow pointing that way. There's our number line. All right. Sorry, it's a bit messy. You'd normally have a bit of space to write those two things out. Now, in C, I've got an awkward looking question, very awkward looking question. It just states that minus 3 is less than or the same as this value of p that's been divided by 4 and then had 2 taken away from it, which is less than 0. Okay. So it's two inequalities going on. Now, all you've got to do is think about doing the same thing to the three parts. You've got the left, the middle, and the right-hand side. Okay, so you've got to think of lines either side down here, and lines either side down here. And anytime you see a symbol, just carry that symbol all the way through. So you could add 2 to everything so far. So let's add 2 to everything, and if we add 2 to everything, we are going to become minus 1 on this side. And we're going to have p over 4 in the middle on its own, because that added 2 to it is going to disappear. That was the point of it. And then less than 2. 0 plus 2 is 2. And then all we've got to do is multiply all the parts through by 4. So that would be minus 4 is less than or the same as p. And then that would be 8. Okay, so our final answer there, because we've got p there on its own in the middle of these two inequalities, the final answer would be that, what I've just written. Minus 4 is less than or the same as p, which is less than 8. Okay, and these are slightly different to represent on a number line, so I'll just do that quickly as well. But again, I have done another example of that in a previous video. So we go from minus 4 all the way up to 8. There's minus 4, there's 8. As long as we've got those values included, it doesn't matter what other numbers we've got in there. Let's just say we've got 0 in there as well, or 2, and there's 0, whatever. That doesn't matter. All right, and then we could put minus 2 in there as well, couldn't we? Yeah, it doesn't even have to be particularly brilliantly to scale, but it would be nice if it was. Minus 4 is less than or the same as this time, so we're going to put that in there, colour in that dot. I'm going to put a non-coloured in dot at the above the 8, and then just join the 2 dots up. That's representing that one on the number line. So that one's for C. That one was for B. All right, there you go. That's how you do all of those slightly more complicated looking ones. Not much different to the other ones, really, are they? Now let's move myself over here and look at the third question. Now this is one where we've got some words. It's a forming inequality question. Just like we can form an equation, we can form inequalities as well. And I wanted to, chuck in questions like this for each particular topic. It's not like you're going to get a question like this for every topic in a paper. That would be unfair. This is what we call an AO3 style question. So the harder types of questions where you're really trying to figure out what it is or what part of maths you really need to do. You can learn all the skills, you now have to apply the skills. That's what these sorts of questions are. And yeah, it'd be the most horrible version of the question that you could get, really, for this particular level. Now, the perimeter of a regular hexagon, 6-sided shape, got a picture there anyway, is larger than the perimeter of an equilateral triangle. Should have an R in equilateral there. Spelling mistake, spotted it. I'm not going to make the video again. Form an inequality and solve to find the range of values for x. Now, but the perimeter is the distance around the outside. We know an equilateral triangle has all the 3 side lengths that are the same, so that would be x plus 6, and that would also be an x plus 6. So the expression that we could write for the perimeter of this triangle is 3x plus 18. Okay, now it says that the hexagon is larger, so if we use the less than symbol, then we can write the expression for the hexagon on the other side. And it wouldn't matter if we did it the other way around. It's just I did that pink triangle first because it was the first one there. All of those lengths are x plus 2, which I'm not going to write. So there are going to be 6 x's, and then there will be 6 lots of 2, so that's 12. Okay, now it's just one of those same questions where you've got the unknowns on both sides, so you just solve it the same way. 3x over here, 6x over here. Let's take away 3x from both sides, leaves us with 3x there. Plus 12 is still there, 18 is still there, and then we put the inequality in the middle. Then we take away 12 from both sides, it leaves us with 6 there, and 3x there. Divide both sides by 3, leaves us with 2 there, and then the x on that side. Now, 2 is less than x, but we want to write it the other way around, really. So x is more than 2, just like we did with the other question up in A. Doesn't always work out to be like that, in all honesty, but these two did. So x is more than 2. We found the range of values for x. It has to be more than 2 for us to have a regular hexagon that has a larger perimeter than the equilateral triangle's perimeter. Okay, if we tried 3 in there, we would get a number that's bigger. If we tried 2, we'd get the same. If we tried a 1, we'd get a number that's smaller. Okay, so I hope that all of that makes sense. I mean, these are pretty tricky questions, but once you get your head around what the symbols mean and what the dots mean above the number lines and everything like that, you just realize it's the same as solving any equations, and if you've got good at those, you can definitely do these. All right, so I hope you enjoyed it. Continue to be systematic in your way of learning and revising for maths. Please do like, subscribe, tell your mates, talk to people about it, say it's all right, it's not too bad, it's not the worst thing in the world you can watch. And yeah, cheers for watching, and I'll see you in the next one. Take care, bye bye.